The previous video cut off, so I'll review a little bit about what we were doing in the previous video. We were looking at exponential growth. The equation for this is y is equal to a times a base b raised to the x power. And we could expand out the base b to be 1 plus r. A would be that initial amount that you start with. R would be the rate of increase. X would be the timing, and y would be the new amount. So an example, a word problem that involves this and a real-life application would be an investment, such as Anne invested $1,000 into an account with an annual interest rate of 2.5%. And that would be the annual interest rate. She made no deposits nor withdrawals on the account for 3 years. That's your timing. If interest was compounded annually, how much would she have in the account? How much would the account balance be after 3 years? So it's important to realize how our formula again is y is equal to A, which is your initial amount. She started with $1,000 times 1 plus the rate. Now the rate is given as a percentage. However, when you put it in the formula, it has to be a decimal. So we have to go ahead and find out 2.5% as a decimal. The way we do it is we take the 2.5, and you could make a percent into a decimal by moving the decimal point 2 places to the left. So the rate that we're interested in using as a decimal is 0.025. So I'm going to add on that amount to 1, since that's my rate. Your rate should always be converted to a decimal. And I'm going to raise that to the x power, which is the time, and that's 3 years. And we're going to do that on the calculator in order to find our answer. 1,000 parentheses 1 plus your rate as a decimal, which is 0.025. Close that out and raise that using the caret symbol to the third power, representing 3 years that have gone by. So your new amount is going to be $1,076, and when you're dealing with money, it's only going to be 2 decimal spots, so it's going to be 8, 9, and the 0 is going to keep it at 9. So that's going to be an 89 cents. So this is the amount of money in Anne's account after this interest took place for 3 years. There's also situations in real world that involve exponential decay. And now the base would be 1 minus the rate. We're taking off a rate since we're decaying. An example of this is depreciation of car values. For instance, you buy a car for $11,900 and $11,900. If the car depreciates or loses value 13% each year, so this is your rate. We're going to make that a decimal. Take your 13, the decimal point is at the end. We're going to move it twice to the left to make it a decimal. 0.13 is the rate that we're going to use R value. And we already know that our initial value was the initial car value, which is 11,900. What would be the value of the car after 4 years? So now that's the timing. So we're going to use this equation. Y is equal to A. A, remember, is your initial amount, which would be the initial purchase price, which is 11,900. Open parentheses. And then we're going to take 1 minus the rate as a decimal, and we already have done that. So we're going to take off 0.13 off of that, raise it to the 4th power since we're interested in how much the car would be after 4 years. And we would do that on the calculator. 11,900 times 1 minus, now we're decaying, so we should be taking off the rate, 0.13. Close that out, raise that to the 4th power since we're interested in 4 years. And it's going to come out to be 6,817.48. So that's 48 cents. $6,817 and $17.48 is how much the car is going to be worth after that amount of years. And this is because this is a situation of depreciation. Cars lose value each year since new cars come out on the market.